So the question, determine the current through each diode in a circuit shown. Use the simplified model. Assume this diode to be similar. Now why do they use the term diodes to be similar? Is because uh, you have to use similar characteristic diode. That means it should have same uh, voltage across the diodes, that is and also the resistance across the through that diode. Now the question is, determine the current ID1 and ID2. Now how to solve this? First of all, according to the simplified model, that means no resistance, RD equal to 0, and VB, that is the barrier voltage, which is equal to 0.7. Now change or replace these two diodes with RD equal to 0 and VB equal to 0.7 volt. So we got the equivalent voltage source or the equivalent circuit as given in the question. Now the question, next thing is to find out a loop. Find out a loop consisting of the resistance and diode such that we can use Kirchhoff voltage law. So applying the Kirchhoff voltage law to the first loop that we have, I can write 15 volt is equal to 0.5 k ohm into I plus 0.7 volt. Now I want I, or you can write I1 as given in the question. I1 is equal to 15 minus 0.7 is 14.3 volt divided by half k, so 0.5 k. So I can write it as 28.6 milliampere. That is I1. Now since at this point I1 is splitting into two currents, that is ID1 and ID2. Since both of the diode have the same characteristics, that is why we have used the term similar. If it were not similar diodes, then the current through each of the diode will be different depending on the resistance offered by the diode. Now since they are similar, both the currents ID1 as well as ID2 will be same. So what is ID1? ID1 is nothing but I1 divided by 2, which is nothing but 14.3 milliampere. Both of the 14.3 milliampere will be passing through both the branches and again coming back to the negative terminal of the voltage source as rejoining them. That is here ID1, here also ID2. So ID1 plus ID2 you will get 28.6 milliampere here. So the question is to find out ID1 and ID2. Now you have got both ID1 and ID2 is also equal to 14.3 milliampere. Now I hope you got the equivalent circuit. Just changing the diode with the yeah, any doubt? Okay. Yeah. So changing the diode with their equivalent voltage. Now once it is done, I am taking the loop. This is the loop I am considering. So with that loop, I am applying KVL. KVL to the first loop. So KVL applying to the first loop, we have 20 volt is equal to 0.7 volt plus 0.7 volt plus I don't know what is the current I. So that will be the current I1 because I1 is moving through that. So I1 into 6.2 kilo. Now 20 minus 1.4, that is 18.6 equal to, that is 18.6 volt equal to 6.2 kilo into I1. From that I1 I will get it as 18.6 divided by 6.2, which is equal to 3 milliampere. So 3 milliampere current is the I1 passing through this, that is diode 1. So this is I1. Now our next question is to find I2. Once we got I2, you can subtract I2 from I1, so that we will get I3. Now this is the potential developed across the diode, that is 0.7. Now this diode D2 and this resistance R2 are in parallel. See, this is nothing but diode D2 in parallel with R2, resistance R2. That means whatever is the voltage developed across this diode is the voltage developed across the resistance R2. Am I right? In that case, whatever is the current should be proportional to that voltage what is developed across this resistance. That is 0.7 volt is equal to I2 into R2. That is 0.7 volt equal to, what is I2? We don't know. I2, R2 is 3.5K. Now what is I2? I2 equal to 0.7 volt by 3.5K, which is nothing but 0.2 milliampere. Now once you got I2, please find out I3. I3 you will get it as around 2.8 milliampere. Subtract. Actually, mic on off. Okay. See, I could have used this loop. If either I2 or I1 I had already known. In the beginning, I did not know, or I don't know I2 or I1. I2 അല്ലെങ്കിൽ I1 എനിക്ക് അറിയാത്തത് കൊണ്ടാണ് എന്താണ് I had gone with the 1. You will have two unknowns, I1 and I2, if you have used the second loop. There is absolutely no wrong in using the loop. You can take any loop. That is, the law permits you to use it. But here you can't use because it will become equation in two variable. To solve equation in two variable, you need two equations. Okay. Yeah. So let us do that. 10 volt is being fed across 2K and 8K. Now assuming that this is open, that means it is reverse biased. This 10 volt is being fed to 2K and 8K in proportional to their resistance. Okay, so what will be the voltage at this point? At V1, V1 is nothing but the voltage across 8K. Voltage across 8K. What is the current? In that 10 volt divided by 2 plus 8K, which is nothing but 1 milliampere current. Across 8K, what is that? V1. So V1 is nothing but 8K into 1 milliampere. So this is the voltage that is developed across 8K ohm resistance. That is nothing but 8 volt. Now you have another loop. Now why this is a loop? Because the negative terminal will be connected to ground. This is also connected to ground. So that is how it becomes a loop. Now again here also the same current, because 4K and 6K, that is 10 volt divided by 6 plus 4K, which is nothing but 1 milliampere. What is the voltage at this point? The voltage at this point is nothing but voltage across 6K. So V2 is nothing but 6K into 1 milliampere, which is nothing but 6 volt. Now at this point V2 you have 6 volt, at V1 you have 8 volt, 8 which is positive connected to the positive P, 6 it is with respect to P, what is the volt? 8. Negative is connected to the lower voltage. So this is forward biased. Forward biased. No problem. Now why we have considered it as a reverse bias? Just to make the circuit simpler. You can do it with considering it as a forward biased also. Problem. So this was our problem. We had a diode placed. Now this 10 volt I am splitting, not splitting actually, I am giving it to two circuits. So 10 volt is fed across 2K, and this is your V1, and here one more 8K is there. This is positive terminal, this is negative terminal. It is being fed. Now you have a diode which is being placed. Similarly you have 4K here, and down you have 6K. This is how you can simplify the circuit. And same 10 volt battery is placed here. 10 volt battery here also, 10 volt battery here also. Now it is very easy to find the voltage at V1. This is voltage at V1, V2. Need not consider whether it is forward biased or reverse biased. You can directly go with the circuit. But here we have assumed this as reverse biased just to make the case easier. Okay. CSIR. Okay. So IV characteristics is given. So for a diode, what we know? We know that RD, that is the diode resistance, is equal to VD, that is the diode voltage, that is voltage applied across the diode, minus VB, that is the barrier voltage, divided by the current flowing through the diode. Okay, VD minus VB by ID. Now we want ID, that is what is given here. ID is equal to VD minus VB divided by RD. Now just find out or equate this to the given equation. V minus 0.7 divided by 500. From this we can write VB is equal to 0.7, that is a silicon diode, and RD, diode resistance, use this 500 ohm. It's a very huge value, 500 ohm. Okay, I can write it as 0.5K because this is point in terms of kilo ohm. Now I can replace this diode with an ideal diode and a 0.7 volt plus a resistance I can add, which is of 0.5K ohm. Now I want to find out the current ID. ID is equal to, or applying the KVL to this loop, we have 10 volt is equal to 1k plus 0.5k, that is 1.5k ohm into I plus 0.7 volt, that is 9.3 volt is equal to 1.5k ohm into I is equal to 9.3 divided by 1.5, which is nothing but please find out the value. What is the value you are getting? 6.2 6.2 milliampere. ഇങ്ങനെ ഒരു ഗ്രാഫ് ഉണ്ടായിരുന്നു നമുക്ക്, ഇങ്ങനെയില്ലേ? ഇതാണ് അപ്രോക്സിമേറ്റ് മോഡൽ. ഇങ്ങനെയല്ല, കുറച്ചും കൂടി ഒരു കേർവ് ഉണ്ടാവണം. Let us take this one. Yeah, so this is called piecewise linear model or approximate model. In that, this is called VB, barrier voltage. The moment it passes barrier voltage, you will have a current in the diode. Now I am taking a dropping a perpendicular down. The perpendicular down is VD, that is voltage applied across the diode. Okay, now what is on the y-axis? You have current in terms of milliampere because it is forward biased. Now that particular point I am taking it as ID. So at this particular VD I will have this much ID. Okay, now what is this slope? Slope is nothing but y by x, this by x. What is y? That is ID. ID by VD minus VB. VD minus VB. That is slope. Now what is slope actually? I by V. But what is inverse of the slope? 1 by slope is nothing but VD minus VB divided by ID. Now what is that slope giving you? Slope is giving you, inverse of the slope is giving you resistance. Resistance in the diode. That is RD or RF. Forward resistance or forward diode. ഈ ഒരു ഫോർമുല ഉപയോഗിച്ചിട്ടാണ് അവിടെ അപ്ലൈ ചെയ്യുന്നു. അവിടെ IV characteristics എന്ന് പറഞ്ഞാൽ തന്നത് ഇതേ ഫോർമുലയാണ്, VD minus VB by ID. There VD is given as V minus VB. VB എന്ന് പറഞ്ഞാൽ 0.7 by RD. RD is equal to 500. That is equal to ID. This one, this particular thing. Now here whatever I know is Kirchhoff voltage law. Just I am applying it. 10 volt is equal to 1 ohm into ID, that is the diode, the current passing. Okay, now the same current will be passing through this diode also, that is why I used ID, plus whatever voltage is developed across this diode, VD. Okay, now this I can write it as ID plus VD minus 10 volt equal to 0. Right? Now what is this ID? ID is given as VD square plus 2VD for VD greater than 0 volt. That is just for base reference given. Now ID I am writing it as VD square plus 2VD plus VD minus 10 volt equal to 0. Now this is an equation of a quadratic equation. VD square plus 3VD minus 10 volt equal to 0. Can you find what is VD? 5 minus 2. Okay, VD minus 5 plus 2. VD square plus 5d. Sorry, let me write 2d. 2vd minus 2vd plus 5vd minus 10v. Minus 10, you need not write v. 10 is enough. Okay, equal to 0. Now vd minus 2 vd into vd plus 5 into vd minus 2. Now that I can write it as vd equal to 2 volt or minus 5 volt. Now 5 volt you can't use because it will become reverse biased. For vd equal to 2 volt, your id have this type of characteristics, that is vd square plus 2vd. So vd value is equal to 2 volt.